Hi all, in this lab 2, let us understand one more pattern within the decoupled architecture. So that is topic queue chaining and load balancing. Let's get started. So we have AWS Cloud and we are implementing one API gateway to front end the customer topic traffic. Okay. And then we have a ride management Lambda, which is actually doing the actual processing of the request. Then it is using the DynamoDB as a backend store. Okay, and then the lambda is sending the messages to SNS topic. Now SNS topic is basically a PubSub model, right? When a topic is subscribed by many other consumers, anytime the message is published to SNS topic, it is sent to all the subscribers, right? So in the previous lab, we were connecting directly the lambda functions with the SNS topic. But now, instead of doing that, we will connect via SQSQ. The reason is if the lambda function is not available or if it is having some exceptions or it is taken for some maintenance purpose, then the messages are lost, right? Now, because of that, we will have a SQSQ in between the SNS topic and the lambda function. Okay, and when the SNS topic is getting any messages, there is a message filtration criteria. Okay, only if certain conditions are met, for example, for the third service, extraordinary service, all the messages will not be going to the extraordinary service. If the messages is having fare is greater than or equal to x, and the distance is greater than or equal to y, only then those messages will be filtered out and sent to the extraordinary service. Okay, now on the client side, we will send one request and the response is coming all the way from the lambdas and it is coming back to the client as a response. Okay. Now let us go to the source code and see how to implement these architectures using the Terraform. Hi all, in this lab, let us understand how to implement a new integration pattern within the decoupled microservices. That pattern is called topic queue chaining and load balancing. Okay, let's get started. So in this case, what we'll be doing is we will be having one SQSQ between the SNS topic and the lambda. Okay. Now, if you go to the source code for the basic infra, first we will have an API gateway. In the API gateway, we will implement one REST API, okay, and this is of the type Edge service, Edge API gateway, and within this we will have one method which is a post method, okay, and the name of the method is submit write completion, okay, and we will be using an integration pattern called AWS proxy, and we'll connect this API to the lambda, okay, so we'll implement one lambda to function to process this particular request coming from the clients over the API gateway. Okay, and we'll define one stage called prod, and we will create a deployment and publish that stage. Okay, so and also we'll configure some logging for the API gateway, some IAM permissions for the logging. Okay, so this is the API gateway configuration. Then let us look at the Lambda function. So within the Lambda, we have multiple functions here. So first one is the submit write application. So submit write completion function will take the request coming from the clients over the API gateway and send it to the SNS topic. Okay. So this Lambda based upon Python code, and the code is here in this folder. Okay. Lambda code write completion, and we are attaching some IAM permissions to this Lambda execution role, and we want the API gateway to trigger this lambda. So that's why the allow triggers API gateway is there. Okay, and the name of the API gateway is here. And we need to configure some environment variables to this lambda. One of them is the DynamoDB table name. The other one is the SNS topic ARN for the topic. Okay. So let us first go to the DynamoDB file. So DynamoDB is a simple configuration. We are creating one table with one of the key, which is a hash key. The name of the key is ID, it's subtype string, and the billing mode is paper request. Okay, and let us go to the other lambdas. So we have submit write completion, then customer notification, which is also a Python based Lambda. And here we wanted to create a mapping with an SQS queue as an event source for this Lambda. Okay. So the SQS queue ARN is here, and the triggers is also SQS queue because we want SQS queue to trigger the Lambda function whenever there is a message, right? And some environment variables. Similarly, for the extraordinary ride also the same thing. We map an SQS queue as an event source and allow an SQS queue to trigger this Lambda, and customer accounting is also the same configuration. And each of these Lambda functions will have a different SQS queue configured for triggering the events, and there are some IAM permissions. Okay. Then let us go to the SQS queues. So the first one is a customer notification. So here we have some policies to send messages to this SQS queue from all the IAM principles. Okay. So similarly for extraordinary service also the same thing. We provide one resource level IAM policy to allow all the IAM principles to send messages. Accounting is also the similar configuration. Okay. Let us go ahead and deploy this stack and see how the entire solution works. Okay. So let me do a Terraform init. Terraform plan. And one more thing we need to keep in mind is if you look at the main.tf, so I'm actually assuming one role when I run this. Okay, that means so the code where I'm running this, okay, I mean the AWS account where I'm running this code is different. Okay, I want to deploy this entire stack into a different AWS account. Okay, using this role. Okay, so I'm doing a cross account deployment. Okay, let us see that. Now Terraform apply is done. Now uh, Terraform plan is done. Terraform apply with auto approve. Let us run that. So Terraform auto apply is also done, and this is the invoke ARL, uh, invoke URL for the API gateway. Okay, and this is the API gateway ID. So what we need to do is let's first go to the AWS console and see how the resources are created. Okay, so let's first go to API gateway. So here there is one API created. The name of the API is wild writes async message one, and the protocol is REST. It's a endpoint type is edge. So if I go inside, I have one resource created called slash submit write completion, and the methods for this is the post, and the integration type is proxy. So here if you look at I'm integrating with another service which is AWS Lambda. So if I go to the Lambda function, for the Lambda, the trigger point is the API gateway, and the code is Python based. So it's a simple code where you get the SNS table ARN and the DynamoDB table ARN via environment variables. And as soon as a message comes, it will send a message to the SNS topic and also puts a message into the DynamoDB. Okay, so this is a simple function. Now let us go to the SNS topic. Okay, so in the SNS topic, we have one topic which the Lambda is sending the messages to, and here you have three subscriptions. Okay, and all of them are SQS queues. Okay, now let us go to the SQS queue, and there are three queues. Okay, one is the accounting service queue, another is the customer notification, the third one is the external service notification. So we have other lambdas also uh, created for each of this SQS queue. Okay, customer accounting, submitted completion we saw just now, customer notification and extraordinary write. Okay, now what we'll be doing is we'll send a message from the client to the API gateway and see how the messages are received. Okay, so this is a command to get the URL. So from the Terraform outputs, and we are sending a simple message where the duration is 420, distance is 5, and fare is 30. So let me send this command. Okay, so I think I've already sent this command earlier. So let us directly go to the console and see whether this message has been received or not. So if I go to SQS queue, let us see whether the messages are created, received. Okay, so the message is received in two queues. One is the accounting service, and there is a customer notification service. And the third one, extraordinary write service queue, does not receive the message because there is a SNS filter which is happening for the topic. So if I go to the SNS configuration for this extraordinary service queue, here the messages will be sent only if this filter criteria is achieved. For example, the fare has to be more than 50 and the distance has to be more than 20. I mean greater than or equal to 50, greater than or equal to 20. Only then the message will be sent to the extraordinary service queue. So that's the reason the first message that we have sent has not been received to this extraordinary service because it is not meeting the criteria. Okay. Now let us send this message. Okay, with this criteria. Now here the fare is 1000, which is more than 50, and the distance is also 40, which is more than 20. So it is meeting the criteria. Now let us go to the console and see whether this message is received or not. So if I just refresh the queues, yeah. So previously the first two queues is having only one message. Now it is two messages because two messages were sent and there is no filtration for the messages for these two queues. Okay. And for the third one, we have a message filtering and it has received the message because it is meeting the criteria. Now, if you go to the Lambda function for the respective queues, we can see that the messages are coming there. Now, if I go to this Lambda, which is customer accounting, go to monitoring and look at the CloudWatch logs. Okay. So we can see the messages are coming. Okay, so whatever the message that we have sent, we are able to receive from here. Similarly, if I go to the extraordinary write lambda and look at the monitoring and look for the CloudWatch logs for this lambda, so here also we receive a message and we can see the messages are coming here. So as you can see, the messages are coming to this particular function. So what we have done so far is we have created SQS topics in between the SNS topic and the Lambda. So when the Lambda is not available for some reason, or it is taken out for the maintenance purpose, or if it is having some exceptions, in all of these cases, the messages are not lost because we are keeping a queue in between. So this is called the topic chaining. So from the SNS topic, we are chaining with SQS queue, and SQS queue is also acting as a buffer load balancers. So if there is a load on the SQS queue, it will also act as a buffer and also it will load balance the messages. Load balance the consumers with the message because it will send one message to one of the consumers. Okay, so this is the topic chain, um, integration pattern that we are demonstrating in this lab.